Hi, thank you for being here today. The members of the group presenting this video are Bucky, Scarleth, Juliya, and Alma. We are part of the amazing PLS 110 class. In this video, we will accomplish 3 goals. First, we will acknowledge the benefits of implementing no-tillage and cover crop systems in California. Then, we will recognize the challenges to adopt cover crops and no-till systems in California. Also, we will show and analyze the outcomes of a 2-month field experiment. Now, what do farmers think about implementing no-tillage systems in California? And what are the obstacles they face to implement these systems? Well, in this class, we have the great opportunity to meet some remarkable farmers and extensionists, and this is what they think about implementing no-tillage systems in California.
I see it as 2 issues or 2 major problems. One is convincing the growers that the research that has been conducted has conclusively settled the issue or the problem as to whether or not no-till production systems will result in 2 things. One, increased or equivalent production, and 2, whether or not it's going to significantly reduce costs. I think one of those issues also has to do with moving the growers' mindset away from how they've conducted tillage practices in the past. And many of these are multi-generational farmers that have worked very hard to actually identify practices that would give them a good stand.
Yeah, one of the things about no-till and cover crops is that it takes a really long time to develop. They've been doing no-till and cover crops in the Midwest for a long time, but it takes about 5 to 7 years before you really start seeing the benefits. So the difficulty here in California is getting farmers to wait 5 to 7 years. If they can, then they'll start seeing some of the benefits of no-till.
Before I started no-tilling, I should have dissed it and have a scraper come in and completely level it, do a perfect job. And that way, when I irrigated it, I'd not have any highs and low spots. I'd be able to get a perfect job, because once you go into no-till, you don't want to back off and till it again, because you're basically destroying what in fact you're trying to accomplish. So
there hasn't been a roadmap for what I'm doing and the way we've done it. People have done it in bits and pieces, but doing it on this size with this many crops, and again, we were starting in on this in the mid-'80s.
Better water penetration, right? So when it rains, you get more rain into the ground. You get typically less weed pressures, less insect pressures. You start rebuilding your organic matter in your soil. You start opening up your soil to more oxygen, more water. Whole bunch of benefits. It takes a while.
when you look at the cost of tillage versus non-tillage, in and of itself, when you look at those reduced passes, you look at the, just think about the capital investment you have in all this heavy-duty equipment. That's a lot of fuel, that's a lot of investment, and it's upkeep, because the tillage equipment itself, the very nature of it wears itself out, running through the ground.
There's an awful lot of good reasons to have a cover crop growing, and so we put an extreme amount in. The whole idea is building the soil, and the cover crops are a big deal for doing that. The other reason for cover crops is water retention.
Along with interviewing no-till and cover crop growers as well as extensionists, we seeded 1.65 acres of land with a cover crop mixture. Half was seeded into no-till soil and half was seeded into till soil. Over the course of 8 weeks, we measured crop emergence, weekly biomass, soil water retention, and rate of evapotranspiration. As shown in the graph, the cover crop emergence recorded 2 weeks after sowing was found to be similar in both tilled and no-tilled plots. The cover crop mixture comprises of the following crops: faba bean, mustard, vetch, and barley. Weekly biomass taken over a period of 1 month was found to be comparable with slightly better performance in the no-till plot. Differences in the mean volumetric water content of the soil showed variation across no-tilled and tilled plot. As shown in the graph, one side of the field in no-till plot has striking difference compared to the other plots. This could be due to the difference in the cover crop mixtures applied and difference in the distribution uniformity of irrigation system. An ET gauge was installed to measure evapotranspiration rate. Readings were taken on daily basis for 3 weeks. ET gauge can be a cheaper way to measure evapotranspiration in the absence of weather station near the farming area. Thus, it can help farmers in scheduling irrigation. We also measured how rapidly soil dries in 2 different plots by using soil moisture data loggers. We conduct this experiment to learn firsthand the short-term benefits and challenges of implementing a cover crop or no-till system. Our results are not conclusive, but were proof helpful as learning tool. To really understand the challenges and benefits, more time and further research is required.
So, to get back to our question, why aren't more California growers adopting these systems? Well, this is a complex answer. Dr. Dahlberg said it can take a long time to see results. Dr. Monk said that convincing the growers that it is worth changing their practices can be a challenge. Michael Crow said that he had difficulties with land prep before switching systems, but that switching also came with tremendous economic benefits. Scott Park discussed the learning curve effect. Considering these expert opinions and our own research results, we have concluded that there are tremendous benefits to switching systems, which include better water penetration in soil, potentially less weed pressure, more organic matter in the soil, aeration, lower costs from reduced fuel use and labor and machinery, better soil health, better water retention. There are also several big factors preventing growers from switching systems, and these include, but are not limited to, time investment, potential reduction in yields, cultural issues, the learning curve effect, and the fact that cover crops do use water.
Cover crops and no-till systems are crucial tools for developing sustainable soil health, yields, and ultimately farmers' income. California growers need to decide if the same intensive farming practices used over and over again will be worth the unforeseen and uncertain future in California's agriculture.
One of the very instructive things in going into no-till is to have patience, because there is the change, this what you call this actual conversion time.
This getting here is you have to have patience. Cover crops, all of what we're doing is no quick fix. So you can't just look at what's my return this year, you've got to look at what's my return over 5 years. And then you weigh that return against what it would be if it was conventional. And yeah, so year 1 and 2, you might have gotten beaten up and lost 300-400 an acre. Year 3, maybe you only lost 200. Year 4, you made 1,200 an acre. Year 5, you made 1,500 an acre. You take all the losses, all the pluses, average it out, and over 5 years, you're good. Now you've got an established system, and the rest of the time, you're on top of it.